Hi, last time we talked about graphing simple quadratic functions where we only had an a and a c with no bx in the middle. And this time we're going to talk about graphing quadratic functions in standard form, ax squared plus bx plus c is equal to y. Many of the things that are listed here are things that we talked about before. If the coefficient of the x squared term is positive, the parabola is going to open upward. If it's negative, it's going to open downward. If its absolute value is greater than 1, then the graph is going to be stretched vertically in comparison to the parent graph, so it will appear to be narrower. And if the absolute value of the coefficient of x squared is between 0 and 1, then the graph will appear to be squashed vertically or shrunk vertically compared to the parent graph, so it will look wider. Its y-intercept before was at 0c when we didn't have a b value. But when we have a b coefficient, the vertex can move off of the y-axis. So in addition to the things that we had before and a change of this, the x-coordinate of the vertex is going to be at negative b over 2a. So if you have the standard form, you can find the x-coordinate of the vertex by taking the value of b and a from the formula and using that little formula, negative b over 2a. It's very handy to remember that. And the y-coordinate of the vertex is found by taking that x value that you found by doing negative b over 2a and substituting it into the equation for x and then simplifying it to see what y is. So this piece here only applied when b was equal to 0. When b is not equal to 0, then this describes where the vertex is. The other pieces up here all still apply. So, if we're going to graph a quadratic function that's in standard form, the first thing to do is find where its vertex is. So I'm going to go through these steps on this equation. So in this quadratic equation, remember you always want to make sure it's in standard form first, so that's from highest to lowest power. This is already in standard form. So a is 3, b is 12, and c is negative 8. So we call h and k the vertex instead of just x and y. They're kind of special, so we give them their own name. So from what we just talked about, the x-coordinate of the vertex, which we call h, is equal to negative b over 2a. So in this case, that gives us negative 12 over 2 times 3, which is 6, and that gives us negative 2. So this is the x-coordinate of our vertex. That means that our vertex, now that I've found its x-coordinate, to find its y-coordinate, we're going to plug that number, negative 2, into the equation for x. So I get y equals 3 times negative 2 squared plus 12 times negative 2 minus 8. So remember, exponents are more important than multiplication. Negative 2 squared is positive 4. Negative 2 times 12 is minus 24. 3 times 4 is 12, minus 24 would be negative 12, minus 8 would be negative 20. So the vertex of our parabola is negative 2, negative 20. Now, if I look at this graph, it only has 10 boxes in each direction from the origin. So that means I'm going to need to change the scale on my graph so that I can fit negative 20 in there for the vertex. But before I start doing that, I want to think about which way this is going to open and whether it's going to be wider or narrower than the parent. Since a is a positive number, this is going to open up. So that means it's going to look something like that. And since 3 is greater than 1, it's going to be stretched vertically. So it's going to look like it's narrower than the parent function. Now, here's the trick. First thing, I want to graph the vertex. My x values are going to fit in here just fine, so I'm just going to have them go count by ones for each box. And when I count by ones for each box, I don't bother labeling it. But my y values need to go down to -20. Since its vertex is there and it opens up, I don't need to go below -20. So I'm going to call this bottom one -20, which means every box here is counting by 2's. So since it's so small, I'm only going to label every other one. So this would be -4, this would be -8, -12, -16, and -20. And then going up, it would be positive 4, 8, 12, 16, and 20. So my vertex is at -2, -20. That's right there. Now, here's a little trick that makes it easier. I'm going to draw my axis of symmetry vertically through the vertex. I use a dotted line because it's not part of the graph, it's just a guideline for it. But now that I've found where the vertex is, the only thing I need to worry about is the 3x squared, as long as I count from the vertex instead of the origin. So if x is, if x is 1, then 3 times 1 squared would be 3. If x is 2, then 3 times 2 squared would be 3 times 4, which is 12. If x is 3, 3 times 3 squared is 3 times 9, which is 27. So from the vertex, not from the origin, I'm going to go right 1 up 3. And remember, every box is 2, so that would be about here. Then I'm going to go right 2 up 12. So that would take me up to -8 here. And then I'm going to go right 3 up 27. Well, 20 is going to bring me to here. And then 2, 4, 6, 7 would be right there. Now I could go with 4. 4 squared would be 16 times 3 would be 48. So that would take me off the top of my graph. Now each of those points that I just plotted, because this is the axis of symmetry, they are reflected the same distance away on the opposite side. So this point here is 1 to the right, so I make another point 1 to the left. This point is 2 to the right, so I'm going to go 2 to the left from the axis of symmetry. And this point is 3 to the right of the axis of symmetry, so I'm going to make its reflection 3 to the left. And when we connect our dots, we want to make the smooth line. We do not want it to be pointy at the bottom. It should be a little bit rounded. And we connect the dots from left to right. So that's what the parabola looks like. Please note that these are not the names of the points I plotted. These numbers tell me how far those points are from the vertex of the parabola. If I wanted to know the names of the points, I could either look at them now. So for example, this one would be -2, -20. This one would be 0, -8. This one would be 1, 7. Okay? Or I could plug the numbers into this equation and figure out what they were. Okay, let's try a couple more examples. So in this problem, A is -2, B is 8, and C is -7. Since A is negative, this is going to open down. So it'll look something like that. And, oh, one other thing that I forgot to mention here. When your equation is in this form, the c value is the y-intercept. Because if you plug 0 in for x, these two terms go away and you're just left with that one. So that's a nice way to get a point that's on your graph without really having to do any work at all. Since the absolute value of a is greater than 1, it's going to be narrower, because it stretches, than the parent. And my vertex, my h value, the x-coordinate of my vertex, is going to be at negative b over 2a, which is going to be negative 8 over 2 times negative 2. Negative 8 divided by negative 4 is positive 2. So the vertex has an x-coordinate of 2, and then to find the y-coordinate, I plug 2 into the original equation. So I get y equals negative 2 times 2 squared plus 8 times 2 minus 7. So 2 squared is 4 times negative 2 is negative 8 plus 16 would be 8 minus 7 is 1. So the vertex of this parabola is at the point 2, 1. So I'm going to go ahead and plot 2 to the right, 1 up. That's going to be my vertex. Remember, we said the y-intercept is going to be 0, negative 7, so I can also plot that. So 1, 2, 3, 4, 5, 6, 7. And now, when I make my little chart, remember, I'm going to make it only for y equals ax squared. So ax squared is negative 2x squared. But when I graph my points, I'm going to count from the vertex instead of the origin. So when I plug in 1, negative 2 times 1 squared is negative 2 times 1, which is negative 2. When I plug in 2, 2 squared is 4, times negative 2 is negative 8. When I plug in 3, 3 squared is 9, times negative 2 is negative 18. So I'm going to draw my axis of symmetry through the vertex. And then from the vertex, I'm going to go right 1 down 2 and draw a point. Right 2 down 8 and draw a point. And the negative 18 is going to take me off the graph, so I'm not going to bother graphing that one. Then I'm going to go back up here. This point was 1 unit to the right of the axis of symmetry, so I'm going to reflect it and draw another point 1 to the left. This point was 2 to the right, and notice my y-intercept is actually the reflection of that point, 2 to the left. And then I'm going to connect the points from left to right with a smooth line. Whoops, I missed a little bit. So that's the graph of negative 2x squared plus 8x minus 7. Moving over here, in this problem, a is 1/2, b is negative 4, and c is 1. So since a is positive, it's going to open up. Since the absolute value of a is between 0 and 1, it's going to look wider than the parent function. Since c is 1, my y-intercept is going to be 0, 1. The x-coordinate of my vertex is negative b over 2a, so that's going to be positive 4 over 2 times 1/2, which is 1. So the x-coordinate of my vertex is 4. And then to find the y-coordinate, I plug 4 into the equation. So y equals 1/2 times 4 squared minus 4 times 4 plus 1. 4 squared is 16, times a half is 8, minus 4 times 4 is minus 16, so that would be negative 8, plus 1 is negative 7. So the y-coordinate of my vertex is negative 7. So I'm going to start by graphing my vertex. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. And I'm going to draw my axis of symmetry, the vertical line that goes through that point. And now when I make my chart, I'm only looking at the 1/2 x squared, and I'm going to count from the vertex. So 1 squared is 1, times a half is a half. 2 squared is 4, times a half is 2. 3 squared is 9, times a half is 4 1/2. 4 squared is 16, times a half is 8. You could even go higher because these numbers are staying fairly small. 5 squared is 25, times a half is 12 1/2. So from my vertex, not from the origin, I'm going to go right 1 up a half. Back to my vertex. Right 2 up 2. Back to my vertex. Right 3 up 4 1/2. Back to my vertex. Right 4 up 8. Well, I was at negative 7, so 8 would be 1 above the horizontal axis. And back to my vertex. Right 5 up 12 1/2. So this is 7, 8, 9, 10, 11, 12 1/2. And then each of those points I can reflect across the axis of symmetry. So this was 1 to the right, I make another one 1 to the left. This was 2 to the right, another one 2 to the left. This was 3 to the right, another one 3 to the left. 4 to the right, 4 to the left. 5 to the right, 5 to the left. Note right there is our y-intercept 0, 1. And then again we connect our points from left to right with a smooth line. So last, we're going to look at a word problem. It says the height of the cables between two telephone poles can be modeled by the equation y equals 0.0024x squared minus 0.1x plus 24, where x and y are measured in feet. To the nearest foot, what is the height of the cable above the ground at its lowest point? Well, a lot of times it's helpful to draw yourself a picture of a problem like this. Here are our two telephone poles, and here is the cable stretched between them. Well, the interesting thing, when you hang a line, a rope, or anything between 2 points, the shape that it hangs in is a parabola. So the vertex of the parabola would be the lowest point. So the coordinates of this point, x, y, the y is the height that we're trying to find. So we need to find the vertex of this parabola. Well, when we just talked about graphing, we learned that the x-coordinate of the vertex, which we call h, is negative b over 2a. So in our equation up here, a is 0.0024, b is negative 0.1, and c is 24. So negative b would be positive 0.1 divided by 0.0024. Now, that's not a number you really can simplify in your head. I mean, you could move the decimals one place to the right and get 1 over 0.024, but you really kind of want a number to plug in there. So we're going to use a calculator to find that value. So 1 divided by 0.024 is 41.666666667, which is actually 41 2/3. Now we want to find the y-coordinate. We want to find the height. So what we need to do is take our equation and we need to substitute 41 2/3 in for x. Now on the calculator, if you have one of these calculators, or if you download an app on your phone that does the same thing, you can actually store this value without rounding it off by hitting the button down here that says STO, and then hitting the green alpha button, and then picking a letter to store it in. I usually choose A because it's right there next to it. So if I do store A after I get an answer, I hit store alpha A and enter. Now that value is stored as the letter A. So if I want to plug that value into an equation, I can just type A instead. So A is now 41 2/3. So what I'm going to do is I'm going to take my equation 0.0024 a squared minus 0.1a plus 24, and I'm going to type that into the calculator just like that. So 0.0024 alpha a squared minus 0.1 alpha a plus 24. And I get exactly 24. So the height of the cable at the lowest point is 24, and the units were feet. Thanks.